Solve the matrix equation for the unknown matrix X. So X is going to be a matrix, mainly because we're using matrices for A and B. So I'm going to rewrite it with the matrices plugged into A and B. So this is going to be 2 multiplied by 4, 6, 1, 3. And this is going to equal matrix B, which is 2, 5, 3, 7, minus 3, big X. So if I had this and I was solving for X, well, the first thing I would do was subtract B. So that's what I'm going to do. Is I'm going to subtract this matrix over. So if I subtract the matrix over to both sides, you get 2 multiplied by 4, 6, 1, 3, minus the matrix 2, 5, 3, 7. And this equals negative 3 big X. Now, in order to combine these two, I need to get rid of this constant here. So I'm going to multiply this constant into this matrix, and if you multiply a constant into a matrix, all you do is multiply every piece of the matrix by that constant. So this is going to be 2 times 4, which is 8, 2 times 6, which is 12, 2 times 1, which is 2, 2 times 3, which is 6, and we're going to subtract that with the matrix 2, 5, 3, 7. And this equals negative 3x. Now, if you subtract matrices, all it's going to be is this piece subtract its same positioned piece. So this is going to be 8 minus 2, which is 6. So my new matrix is going to be 6. And then 12 minus 5 is going to be 7. And then you have 2 minus 3, which is going to be negative 1. 6 minus 7, which is negative 1. And this equals negative 3 big X. Now, I got to get rid of that constant to get X by itself. So I'm going to multiply. I can't divide by negative 3, but I can multiply both sides by negative 1/3. So this reduces with this. And we end up getting negative 1/3 multiplied by 6. So that's going to be negative 2. And then 7 multiplied by 1/3 is going to be 7/3. Negative 1 multiplied by negative 1/3 is positive 1/3. And then it's positive 1/3 again. And then this equals big X. So we have it solved. The big matrix X is going to be negative 2, negative 7/3, 1/3, 1/3.